Greetings, my fellow Almonticans, and welcome back to Broadcast from the Bunker. Little shout out to Elmont Research today. All right, hopefully someday you guys will be able to solve this crazy crisis we're in right now. Anyways, today's hot topic. We are in a new unit going into weathering and erosion. Today we're talking about physical weathering. Your due now is 21 to 24. Just to remind you real quick for homework, make sure you complete the rock and mineral castle summary. It was up yesterday. I understand internet issues, but get it done as soon as you can. And of course, there's a new assignment on the GC. It's called Banding the Penny. Interesting article, a couple questions, and I'm curious what your feedback is on that one. So please get those two completed as soon as possible. And last but not least, thank you for your continued persistence and patience with the internet issues, making it challenging to complete these assignments. I understand. Just please keep at it. All right. Without further ado, take a few minutes. Numbers 21 to 24 in the GC. Okay, hopefully you put some love into those like you always do. Starting on 21, on March 21st, Equinox Day, two observers, one at 45 north and the other 45 south, watch the rising sun. In which direction must they look? Well, it doesn't matter where you are on Earth, folks. The sun will always rise in the easterly direction and set in the westerly direction. Doesn't matter which hemisphere you're in. So you got to find one that says toward the east, and that would... right there, both observers must look toward the east. All right. Again, that sun is moving at a rate of 45 degrees per hour across the sky, and that's because of the rate of the Earth's rotation. All right. '22. Why do stars appear to move through the night sky at a rate of 15 degrees per hour? Speak of the devil, there it is. That again is because the Earth's rotationary rate, it is 15 degrees per hour. So find one that says that. There it is. Earth actually rotates at 15 degrees per hour. Remember, if the Earth sped up, our days would be shorter. And if the Earth slowed down, our days would be longer. All right, 23. The tilt of the Earth on its axis is the cause of the Earth. Well, we know that tilt causes the seasons, and it's going to also cause things related to the seasons. So that would be your temperature fluctuations as you go through the seasons, your changing length of day and night, which, by the way, we are currently getting longer and longer, as you know, in the day, and we just passed the 12-hour point not too long ago on the equinox day. But anyways, you're looking for something that was seasonally related, and of course, there it is, changing length of day and night. If there was no tilt, every day would be 12-hour day, 12-hour night. All right, and number 24, during the period of 1 year, what would be the greatest altitude of sun at the North Pole? Well, a little bit abstract, but remember on an equinox day, the sun will be right at the horizon at the poles. And then from there, let's say you're at the North Pole, as you head towards summer, it'll gradually get higher and higher until June 21st. And that angle of sunlight is going to be directly related to the Earth's tilt. So if at equinox day it's at 0 degrees at the horizon, then by the time you get to June 21st, it will be 23.5 degrees above that horizon at noon. So we're going with that magical 23.5 degree number right there. Okay? All right, any further questions on these, please put it down in the YouTube comments, or of course, remind me your questions as well. All right, let's jump into the lesson. All right, here we go. A couple of beautiful pictures on the bottom there. You can see rock being broken down, transported. That's what this unit's all about, transporting and breaking down material on the Earth's surface. Okay. classic picture there. You guys all familiar with the Sphinx? Interesting quick story. The Sphinx started speeding up, breaking down in recent times. There was a concert that used to be, lots of concerts, used to be held in Egypt, and they would do them near these monuments because it would be amazing backdrop. But it turns out that the vibration from the bass from the speakers was actually speeding up the breaking down the weathering of these monuments, so they had to move the concerts back. Anyway, you have a bunch of pictures on the next slide in your GC there. See if you can figure out what's going on in those pictures. And here they are. Right? We'll label these at the summary, but if you could just take a minute, try to figure out what's going on at each picture. Okay? Okay. Make sure you read through this. Very interesting little paragraph there. All right, there's your definition for weathering: the breakdown of rocks on or at the Earth's surface into smaller fragments or sediments. Hold on a second. Again, the breakdown of rocks on or at the Earth's surface into smaller fragments. This is called weathering. And there are two types: physical, which sometimes we call mechanical, and of course chemical. We're going to focus on the physical today. All right. All right, so we'll start with physical weathering. It's a breakdown of rock in the different sizes or shapes. The key here is no chemical change. It just makes the rocks get smaller and smaller. They don't undergo a chemical change. And there are many different types, and we'll go through those types. Beautiful pictures here. These are by both wind and water erosion. I know in the desert you're thinking water erosion, but yeah, believe it or not, when it does rain in the desert, it rains pretty hard, and it does take its toll on the rock structures there. But of course, a lot of wind as well. There's your classic Grand Canyon picture. The Colorado River is cutting down. That is water erosion. All right. Starting out with frost wedging. Water is amazing when it expands. It'll crack almost anything. We talked about having antifreeze in your car engine. If it goes bad, it will also crack part of your engine block there. So you want to make sure you're not a victim to frost wedging. Sometimes called frost action. When water freezes, it expands, and of course will start to break up rocks. That's physical weathering. That's why we get potholes. It's a pretty amazing force of nature. All right. Then you have root action. Plants are very strong as well. They will go wherever they can find moisture, and if they find it, they keep growing toward it. And that, of course, will crack rock as well. If you have a tree that's close to your house, well, you know, I'm not a proponent of cutting down trees all over the place, but it will start to grow into your foundation because cement likes to hang on to water. So just keep that in mind. Also called root action. Plants' roots grow in between the cracks of rocks. They'll get bigger and bigger until eventually it just splits it. All right. Then there's abrasion. I'm sure we've all been running around and fell down on the gym floor, and you hear that on your skin. That's an abrasion, and you get this red friction burn on your skin. Well, nature does it as well. Wind is one way to do it. Water is another way to do it. And both of these will rub sediment smoother, turning it more rounded. All right, that's abrasion. When particles collide and rub against one another, they will get smaller, they'll get rounder, they'll lose mass. And they become these gorgeous stones, which I'm sure you've seen, like spa therapies. You get these beautiful rocks like this. Those have been in a river for a long, long time. Okay? Then there's the next one called exfoliation. When you heat something up, you know it expands. When it cools, it contracts. Well, eventually, that expansion, contraction, eventually is going to wear something out. Even a rock can't take that forever. They call it exfoliation. So it's hot in the day, it's going to expand. And then at night, temperature drops, it's going to get cold, and it'll contract. Eventually, it cracks. Now, we talked about this on the moon, right? The moon's surface, the difference between the light and the dark part is about 400 degrees. So during its lit time, the rock expands, and during its dark time, it contracts, and it has made the moon's surface all broken down into a fine powder almost, and that is because of exfoliation. All right, and there it is, heating up due to expansion or expansion due to heating up, eventually breaking it down. And that's why you'll see sidewalks with these expansion joints in them, because during the day they'll expand and at night contract. And if there was no expansion joints, then the concrete would crack a lot quicker. Same thing with bridges. You ever go over a bridge, you're driving over a bridge, you hear da-dump, da-dump, da-dump. Well, those are expansion joints. And during the day, the bridge has to be able to come together, and at night it needs to be able to stretch without falling apart. So they put these expansion joints in the bridges as well. All right. So anyway, like I promised, we're going to label these pictures. Let's see how you did. The first one, you see a bunch of tree roots growing in it, so hopefully you labeled that one plant action or root action. Second one here, you can see snow in the background. Looks like a cold place. Water got in there and cracked it. We call that frost wedging or frost action. Same thing with C. You can see the snow there. Pretty amazing force of nature. D looks like water's flowing over the rocks, right? So we're going to go with a classic abrasion there by rivers. Over here, looks like the sun is beating down on that rock, and it seems to be peeling it in layers. That's that exfoliation for you. And if you'll zoom in on that, you'll see ice in that crack there. Again, that's a frost action. Okay. Double check your answers there. All right. Couple of Regents questions. Try to wrap it up. Which is the best example of physical weathering? Well, you went through all of these. The cracking of rock caused by the freezing and thawing of water, right? AKA frost action. And there it is. Second one here, which factor has the least effect on the weathering of a rock? Well, composition is what it's made of, and if it's hard versus soft minerals, that makes a big difference. We're looking for the least. Exposure of the rock in the atmosphere, well, wind and rain are all because of the atmosphere. That makes a huge difference. The number of fossils, however, well, that doesn't matter, right? That's not going to affect the rate of weathering so much. At high elevations in New York State, which is the most common form of weathering? Well, if you've ever been hiking, hopefully if you haven't, you will someday. When you get up to the top of a mountain, it's very cold and you get a lot of big temperature fluctuations. So at those high elevations, you're going to get this alternate freeze thawing frequently, not just in the winter. It could be all year round, because the higher you go, the colder it gets, and you'll get a big swing of temperature. Okay? So hopefully you did all right on that. Just a little reminder for you. How can I ask questions? Again, remember, type them into the YouTube comment section below, or again, send them to remind at that code right there. All right? Hope to see you guys soon.